Hello, welcome to my channel. Here we are discussing the topic electricity for Edexcel IGCSE Physics examination. That too questions from the past 4 to 5 years of Edexcel exam board. In fact, this is the third part of this series, and the link to the other two parts of the series are given in the description box. So before we start, please like and share my videos and also subscribe to my channel so that you can get notification about my new videos. In fact, these videos are good for all exam boards because most of the exam boards or all exam boards cover the topic electricity and circuits. I shall show you how to answer them. So let us start with the first question here, question number 13, because the first 12 questions are included in the other parts. So it says that there is a lamp X which has 7 identical bulbs. There are 7 identical bulbs. And the question is, give a disadvantage of connecting the bulbs in series. So you have studied that if the components are connected in series, the disadvantage is if any one of the component fails to work, all others will stop working. So let us put it as an answer. So if one bulb fails, all other bulbs will turn off. Now suggest an advantage of connecting the bulbs in series. First of all, the advantage is series connection use only few wires. So we can write it. It uses few wires. Uses only few wires. As an other advantage, we can say like we can control all the bulbs with a single switch. All bulbs can be controlled with a single switch. Using a single switch. Now the next part of the question, each bulb has working resistance of 390 ohms. So this is the resistance of each bulb and each one has a voltage of 33. The question is, state the formula linking voltage, current and resistance. This is what is Ohm's law says. According to Ohm's law, voltage is the product of current and resistance. So those who are using the triangle form for the equations, you can write current and resistance and voltages on the top part of the triangle. Now next part of the question is calculate the current in each bulb. So in the previous equation, Ohm's law, according to Ohm's law, V is the product of I and R, and we can keep I as the subject. It is V over R. The voltage is 33 and the resistance is 390. Please make use of your calculator to get the answer. It gives an answer of 0.085 amps. Now next part is calculating the energy transferred to lamp X. Energy transferred. So energy E to lamp X when it is used for 2.5 hours. You know the time is given here. When the time is given in hours, you have to convert it into seconds. 2.5 in 1 hour 60 minutes and in each minute 60 seconds. So altogether this much seconds. Now calculate the energy transferred. So you have studied an equation relating energy time, that is power is the energy transferred per unit time. So those who are putting or using a triangle for this, you can keep E and the rest of the two letters P and T as a product. Remember, only a product is coming in the triangle bottom part. Now when you want to calculate energy, cover this energy part. The rest of the equation appears as P times T. So let us write it as energy. It is the product of power and time. And also we know that power is the product of voltage and current. Here the voltage and current only provided. Power is not given directly, times T. So let us write it as the voltage is 33. The current we calculated it as 0.085 times the time is 2.5 times 60 times 60. But here don't forget to put 7, multiply with the 7, because it is asking what is the energy transferred to the lamp X. Lamp X has 7 bulbs. So multiply this with the 7. So here it multiply with the 7. Don't forget the step. Okay. Multiplying with the 7 because there are 7 bulbs. So 7 times 33 times. So make use of your calculator to calculate. This will give an answer. 180,000 joules. So energy transferred is 180,000. 180,000 joules. Now let us see the next part of the question. Another decorating lamp uses 5 of the same 390 bulbs, identical bulbs connected in series. Both lamps are mains operated, so same voltage. Explain how the brightness of a single bulb in lamp Y compares with the lamp X. So they are asking us to compare lamp X and Y. So let us write it as lamp X here, and here it is lamp Y. So lamp X, that is, it contains 7 bulbs, whereas lamp Y, it contains only 5 bulbs. This is what is given. So let us see the resistance. Resistance of each bulb is 390 ohms. This is what is given. And also the voltage. Remember, all these bulbs are connected in series. Therefore, the supply voltage is divided among the same 7 bulbs. Therefore, let us see what is the voltage across each bulb. Voltage across each bulb is, it is 230. It is mains operated, but it is divided by 7 bulbs. So each bulb is getting around 32.6 volt. So let us see what is the current passing through each bulb. So the current through each bulb, its voltage is 32.6, and each one has a resistance of 390. This will give 0.085. In fact, this is the part we already finished before the step. So each bulb is getting a current of 0.085. Let's see the same thing for lamp Y, and we know that there are 5 bulbs, and the resistance of each bulb, it is 390 ohms because they are using identical bulbs. Now here let us see what is the voltage across each bulb. So the voltage of each bulb is mains operated. So 230 is divided among these 5 bulbs. Therefore, each one is getting a voltage of 40, it's somewhat 41 volts. Each one is getting 41 volts. So what is the current passing through each bulb? So current of each one. Current passing through each bulb is the voltage 41 over the resistance 390. This is giving a current of 0.12 amperes. Now let us compare the currents. The current in lamp X is less than the current in lamp Y. Okay. So you see lamp X, each bulb is having a current of 0.085, whereas in lamp Y, current through each bulb is 0.12 amperes. Therefore, definitely, so more current in lamp Y, therefore the brightness. So brightness of lamp, how the brightness of a single lamp, brightness of lamp Y, brightness of each bulb in lamp Y is more than lamp X, because each bulb in lamp Y is getting more current, so more brightness. Let us move on to the next question. There is a hair dryer given here. State which wire in the hair dryer should be in series with the fuse. So please remember, the fuse wire is always connected to the live. Fuse, not fuse wire. The fuse is connected always in series to the live wire. Live wire. Now you have learned that there are 3 wires. So live wire, then which carries the main current, then it is the earth wire, and the next one is the neutral wire. Live wire, neutral wire, and the earth wire. So live wire carries the main current, therefore fuse must be connected to the live wire only. Earth wire is connected to the earthing for protection. Now the next part of the question, the fuse is an electrical safety. State 2 other electrical safety features that can be used in the main operated domestic appliances. So one is just like fuse, we have circuit breaker, and another one is the earth wire, earthing the earth wire, or we can say earthing. Let us see the next part of the question. The hair dryer has a current of 9.6 ampere. The main supply voltage is 230 volt. State the formula linking power, current and voltage. So as we know, power is the product of current and voltage. Power is current times voltage. Current times voltage. Then the question is, calculate the power of the hair dryer and give the unit. Calculate the power. So power is I times V, and here the current is given and also V is given. So just substitute the values. The current of 9.6 amperes times it is mains operated times 230. So this will give an answer of, please make use of your calculator to get the answer. It is giving an answer of 2200 watts. So power is 2200 and the unit is watts. Now the next part of the question is, the hair dryer contains a coil of wire which is used to heat air passing through the hair dryer. Explain why the coil of wire heats up when there is a current in it. And we know that most of the heating devices, they are having a coil of wire. Okay, so now the question is, explain why the coil of wire heats up when there is a current flowing through it. Because the coil of wire is having a high resistance. So let us put it as an answer. The coil of wire has a high resistance. It has a high resistance. When there is a current flow through the wire, when there is a current flow that is through the coil, the electrons, current flow means the electron flow. The electrons lose energy as they flow through the coil, and this is happening. This is due to the collision of electrons. I'm writing the short form for electrons. Collision of electrons with the lattice ions. And electrons are losing energy. That means this collision is generating heat. It generates heat. Then we can add that higher the resistance, more is the heat generated. Higher the resistance, more is the heat generated. Next one, explain how a fuse protects a domestic appliance. This question is answered already in the first part of this video. And we know we are using a fuse to protect the appliances. In the fuse, there is a fuse wire. So when a very high current is flowing through the fuse, very high current means the current more than indicated on the fuse. When a high current is passing through the fuse, it heats up the fuse wire and it melts. And produce a gap. This prevents the further flow of current. I'm writing CKT through the circuit, the short form of circuit, Just to save time and space, I'm using it, but try to write the complete full words for the exam. Now the next one is, it's a question from January 21. The diagram shows some apparatus used to find the mass of an object. So there is an apparatus given. Let us answer the first question. Let us see the first question. Draw the circuit diagram for this electrical circuit. Yes. So here the variable resistor has been drawn for you. So it's already they are telling that there are two metal foil, that is piece 1 and this is metal foil piece 2. When more mass is added, the elastic string, you can see there is a pulley and masses, you can add masses here. When more masses are adding, what is happening? The elastic string stretches. So there is an elastic string, it stretches, and the small piece of the metal foil moves to the right. So this piece will move towards the right side. That means when it is moving towards the right side, this changes the resistance of this foil 2. The foil 2 and the metal foil 1 together acts as a variable resistor here. So that variable resistor symbol is already provided here for you, and you have to complete the circuit with the other required components. You have to complete the circuit. So it's given the variable resistor has been drawn for you. So let us see the other components used here. There is an ammeter. So you have to connect an ammeter. There is a cell, and of course this is the positive side of the cell. So it is positive, negative. We have a cell, and there is a fixed resistor. This is a fixed resistor. So of course the connection wires are there. So let us complete it. There is a variable resistor. Then so for this variable resistor, let us connect an ammeter here. Then there is a cell, a fixed resistor. Now the next part of the question is, so let us see whether we included everything. We have included the ammeter, we have included the cell positive. Here is a cell positive and negative. The variable resistor, of course, it is given, and the fixed resistor R. The next part is, draw a voltmeter on the diagram to measure the voltage of the variable resistor. Draw a voltmeter across the variable resistor. We know that we are connecting voltmeters only parallel to the component. So here we can connect the voltmeter to measure the voltage. And also you can write it here, voltmeter connected parallel to the variable resistor. Voltmeter connected parallel to the variable resistor. Now the next part of the question is, explain how the voltage across the variable resistor changes if more mass is added to the elastic string. See, when more mass is added, the wire stretches. The wire stretches and the resistance of the wire increases. So when we are adding more masses, what is happening is, the wire stretches means here the foil will move towards the right. That means when the foil is coming at this position, as an example, if the foil is coming at this position, now this much length of the foil is included in the circuit now. Earlier it was a less length. Earlier only this much length was included. But if the foil comes this position, a new length, say length L1, this much length of the foil is included in the circuit. That means the resistance of this much length of wire is included in the circuit now. That is why the resistance of the variable resistor increases here when more masses are added. So let us put it as an answer. When mass is when mass is increased, when mass increases, that is the added mass, when added mass increases, the wire stretches. And the resistance of the wire increases. Wire stretches and the resistance increases. That means the variable resistance, variable resistance increasing, variable resistance increasing. So when the variable resistance increasing, what is happening is the total resistance of the circuit is increasing. That means R total increases. So I'm putting the symbol increases just to save space and time, but exam, please write the words R total increases. So when R total increases, the circuit current, as the resistance increases, the current will decrease. Circuit current decreases. Downward arrow I'm showing to show that it is decreasing. So when the circuit current is decreasing, there is no place here, so I'm putting it here. The next step is coming here. When the circuit current decreases, definitely the voltage across the fixed resistor R decreases. So the fixed resistor is, this is the fixed resistor, and this is the variable resistor, VR. I'm writing VR, variable resistor. So voltage drop across the fixed resistor decreases. When the voltage drop across the fixed resistor decreases, the voltage drop of the variable resistor, voltage of the variable resistor, this is increasing since the battery or the cell, since the cell voltage is constant, since the cell voltage is constant. So what I have explained here is, these two resistors are connected in series only, and the cell voltage is divided among the variable resistor and the fixed resistor. So when one of them decreases, the other one has to increase to keep the cell voltage as a constant. So that part I can just show you this way. The cell voltage is a constant. So V of the cell is the sum of voltage of the variable resistor plus the voltage of the fixed resistor. So here, when the voltage of the fixed resistor decreases, the voltage of the variable resistor should increase, or it is increasing to keep the cell voltage as a constant. Now let us see the next part of the question. I think this is a graph. They studied measure the current for different voltages. So the values are tabulated here. State the independent variable in the student's investigation. The independent variable means, as you know, it is the variable that we control and keep, that we are controlling it. It's not control variable. Control variable means the one we are keeping fixed. So there are three types of variable: control variable, then it is the independent one, and the dependent one. Control variable means it's fixed throughout. Independent variable is what we control and keep. We control and keep. We control in the experiment. Dependent variable means this is we measure it in the experiment. We measure it. We measure it in the experiment. Even the independent variable we are measuring, but we fix it. We control and keep. So as an example, you can see the voltage. He is controlling and keeping as 0, 2, 4 in steps of 2. He is changing, varying and keeping. So we can say the independent variable, you can say it as also we control it, or we vary and keep. I can say even that way also. So this is the independent variable. This is the independent variable. So in another way we can say independent variable is what we vary in the experiment. What we vary and measure it in the experiment. We vary and control it. We vary in the experiment. You can use we control in the experiment, or if you are confused, I can use the other word we vary. We vary in the experiment. Now plot the students' results on the grid and also draw a line of best fit. See, I just copied, to save time, I just copied the table with the voltage and current here. Now here they are not telling you uh, which value you will keep it in the x-axis and which value you plot on the y-axis. But we know that always the independent variable is on the x-axis. So here, when you plot a graph, the first step is label the x and y axis with the proper units. So here we have the x-axis here. So let us label the x-axis. We are keeping independent variable on the x-axis, and here the voltage is the independent variable. So you have to label that. So voltage, and the unit here it is in volts. We are measuring it in volts. Similarly, on the y-axis, it is the current. It is the current. It is measured in milliamperes. So that you can get from the column title. Look at the column title for the correct unit. Now the next thing is you have to mark a proper scale. So as an example, the voltage is varying from 0 to 8. So 0 to 8 means I think each big uh, square can be considered as 2. The next one it is 4, then it is 6, 8 and 10, because we have to go till 8 only. Then the current is varying from 0 to 14. 0 to 14 also we can take each big box as 2, 4, 6, 8. No, we have to take each one as 1, but I'm just marking it as 2. So this is 4, next to one is 6, 8, 2, 4, 6, 8, 10. No, this should be 4, this should be 2, then this should be 6, this should be 8, 10, 12 and 14. Now let us mark the numbers. When the voltage is 0, current is 0. So this is starting from 0, 0. So origin is 0, 0. So let us mark that also. 0, 0 origin. Voltage 0, current is 0. Voltage 2, current is 4. Voltage 2, current is 4. For 6, sorry, for 4 it is 7. Voltage 4, it is 7 is middle of 6 and 8. Then for 6 it is 11. For 6 it is 11 here. Then for 8 volt it is 14. For 8 it is 14. So 14 is here. Now the next one is draw a line of best fit. It is judged by your eyes. Best fit judged by the eyes. So we can join all the points. So let us join them. You have to use a ruler to join the points and join with the origin. So this is the line we are getting. It should be a straight line. And another thing what you have to remember is when you are plotting a graph, your graph must be at least more than half of the graph should use more than half of the graph space. Now the next part of the question is, there is a diagram and a fixed resistor 270 ohms. So this is a fixed resistor. So let us mark it as fixed resistor R, and there is a variable power supply. Draw meters on the diagram to measure the voltage. So you have to measure the voltage and the current in the LED. So which one is the LED? So this is the LED. So the light arrows are going out. It shows that it is emitting light. So LED, light emitting diode. This is the symbol of LED. Now we want to measure the voltage and current. So as we know, the voltmeter is across the LED. So we are connecting a voltmeter across the LED. And the ammeter must be in series to the circuit. So we connected an ammeter, we connected a voltmeter across the LED. Current in the LED. Current in the LED means you can, since it is in series, the same current is flowing, you can keep the ammeter here, or you can keep the ammeter at this position also. This is also correct. Now another table is given with voltage and current. Again, plot the results on the grid. One of the results is anomalous on the graph. Draw a circle around the anomalous result and draw a line of best fit. Even here also, to save time, I have just copied the table here. It is voltage and current, and also in this question they are not telling what is marked on the x-axis, what is marked on the y-axis, but we know that here the voltage is, they are varying the voltage in steps like 3.3, 5.4. So they are varying this voltage and they keep it fixed in the experiment, vary and keep it fixed. Therefore voltage is the independent variable. So usually independent variable will go on the x-axis. So this is the x-axis. So on the x-axis we mark the voltage, label the x and y axis. Voltage in volts, and this is 0, 0, and the current axis is the y axis. So current, and it is measured in milliamps. Now next one, let us decide the scale. The voltage is varying from 0 to 0.6. So 0 to 0.6 means I think each one can be taken as zero point 0.1. So 1, 2, 3, 4, 5, 6. Okay. So each one big square can be taken as 0 0.1. The next one 0 0.2. Then 0 0.3, 4, 5, and 6. So we have marked all the voltages. Then let us decide the scale for the y-axis. The current is varying from 0 to 15. 0 to 15. So 0 to 15, we have to go up to 15. So we can take each one as 5, 10, 15. So each 2.5, 5, 7.5, 10, then 12.5 and 15. Yes. So each one can be taken as 2.5. 2.5. Next 5, 7.5, 10, 7.5. Then this is 12.5 and this is 15. Now let us mark them. When the voltage is 0, current is 0. When it is 0.3, this is 0.5. 0.3. So 0.3 means here 0.3 and 0.5. 0.5 means, so now let us see what is the value of each division, each small square. So here 2.5 is 10 divisions. So 2.5, 10 divisions. Let me write it here. 2.5 corresponds to 10 divisions. Therefore, how much is one division? One division is 2.5 over 10. So it is 0.25. Dividing 2.5 by 10, 0.25 is one division. Okay, so our number is 0.5. So 0.25 and the second division will be 0.5. So for a voltage of 0.3, so this is the position. This is the position. Next to 1.35, 0.35 means it is between 3 and 4. 0.35, it is 2.5. So 2.5 is this point. Then 0.4 is 1.5. 0.4 is 1.5. 1.5 means 0.2, 5.5, 0.75, 1, 1.25 and 1.5. So this is the point. Now 0.45, the number is 2. 45, the number is 2 means it is here. Then 0.5, it is 4.5. 0.5 and 4.5 will be here. Then 0.55, it is 9. 0.55 and 9. 9 means 7.5. So it will be 9 here. Then for 0.6, it is 15. 0.6, the maximum current is 15. So we marked all the points. Now the next part is there is an anomalous value. You have to encircle it and also draw a curve of best fit. You can say this is the anomalous value. So this is the anomalous value. And now we can plot the graph joining the points from the origin, because origin is also given 0, 0. So we have to join the 0 and slowly draw the line So we have marked the anomalous value and to the next part of the question. Give a reason why a line graph is the best way of showing these results. So here you can see that the data given are continuous and not discrete. Therefore, line graph is the best. So let us put it as an answer. The data given are continuous. So the line graph is the best one. Say the formula linking voltage, current and resistance. Many times we answered this question. This is Ohm's law. Voltage is the product of current I and resistance R. Next part is any current larger than 15 milliampere will permanently damage the LED. The resistor in the circuit has a resistance of 270 ohm. I use the results from the investigation to determine the maximum voltage of the power supply without damaging the LED. Here you can see that the current, maximum current is 15 milliampere. Beyond that, that will damage the LED. And from the table you see that when 15 milliampere current flowing, the time the voltage is 0.6 from the table. Voltage and current, the last set of reading from the table. For a voltage of 0.6, the current is 15 milliampere. That means beyond 15 milliampere will damage the LED, means the maximum voltage that can be applied to the LED is 0.6. So let me write it as Vmax, Vmax of LED. This is 0.6 volts. Now determine the maximum voltage of the power supply. And since these are connected in series, the battery voltage or the power supply voltage, let me write it as V battery. This is shared among the LED and the fixed resistor. So battery voltage is a sum of these two. And here the battery voltage is we have to calculate VR first. And the LED voltage, we know that it is 0.6 plus VR is the current flowing through the resistor times the resistance value. So which is 0.6 plus the current we have already seen that 0.015 and the resistance value is 270. So this will give you, please make use of your calculator to calculate the value. This will give you an answer of total. This will give an answer of 0.4 points. So this will be 0.6 plus this part is 4.05. So total is 4.7 volt. So this is the maximum value of the battery, maximum voltage of the power supply or the battery without damaging the LED. It must be 4.7 volt. Now let us go to the next question. The diagram shows a circuit containing a cell, two switches and two resistors. A light emitting diode LED is represented using the symbol light emitting diode. Draw an LED on the circuit diagram that will indicate. And as you know, these LEDs are used as an indicators to indicate the presence of current or current is flowing through the circuit. So we want to use this LED as an indicator in branch R1. This is R1. So to know whether there is a current, if we are connecting an LED, so the LED must be connected in series to branch R1 or first branch. So this shows that it is emitting current. It is emitting the light emitting diode. Draw LED on the circuit diagram that will indicate when there is a current in the resistor R1. So this is the position of the then both switches both switches in the circuit are now closed. Draw an ammeter on the circuit diagram that will measure the current in the cell. Current in the cell means it should be connected closer to the cell, and also we know that the ammeters are connected in series. Then they measure the voltage across the cell. The voltage across the cell is 4.5. Explain how the voltage across R2 compares with the voltage across the cell. As you see, the cell and resistance R1, R2, all of them are connected parallel. Therefore, voltage drop across R1 equal to voltage drop across R2, which is same as the battery voltage. So let us put it as an answer. How the voltage across R2. So we know that voltage of the cell is equal to voltage of resistor R1, which is equal to voltage of resistor R2. As they connected in parallel, as they are connected parallel. Now we have to compare R2 with the cell. Therefore, voltage of the cell must be equal to the voltage of R2. They are equal. Now the switch S1 is now open with the switch S2 remain closed. State the formula linking energy transferred, charge and voltage. The formula linking energy transferred, charge and voltage. We studied the equation for or the definition for voltage. It is energy transferred by unit charge. So those who are putting in a triangle, it's energy here, voltage times Q. So if you want to know the equation or to calculate energy, cover the energy letter. The rest of the equation appears as V times Q. So we can say energy is V times Q. Formula linking energy and charge. Energy is the product of voltage and charge. The next part is the voltage across a cell stays constant at 4.5. Calculate the charge transferred through the cell when the cell transfers 4.1 joule of energy. We have the equation. Energy is the product of voltage and Q. Calculate the charge transferred. So making Q as the subject. E over V. Energy is 4.1 and voltage is 4.5. Please make use of your calculator. This will give an answer of 0.911 coulomb. So 0.911, the symbol coulomb is already given. Now next part of the question is, a student investigate how current in resistor R2 varies with the voltage across it. Current in resistor R2 varies with the voltage. Describe how the circuit should be modified for the student to do this investigation. How current varies in R2, the branch R2. Let us see the circuit again. This is branch R2, and here they said switch S1 is open and S2 is switch 2 is closed. S1 is open means no current is flowing through S1. Now the current is flowing through only switch 2. Now what are the modifications the student has to make in the circuit for this investigation? How the current varies with the voltage across it. That means we have to keep different voltage across the resistor R2 and note the corresponding current. So to vary the voltage, either you have to use a variable power supply. So in this circuit, it's already given a fixed power supply or a cell it is given. So that part we cannot change. So the other alternative is he can use a variable resistor. So connect a variable resistor. To vary the voltage across resistor R2. A variable resistor to vary the voltage across R2. Connect a variable resistor in series to the circuit to vary the voltage across R2. The second one is he has to measure the voltage. So connect a voltmeter parallel to the resistor R2. So these are the modifications. So connect a variable resistor, that too series to the circuit. This is the first modification he has to do. The second one is connect a voltmeter parallel to the resistor R2. So these are the two modifications he has to do. The next one is a circuit is shown again. Calculate the voltage across the thermistor. So here a thermistor is given. So let me write it as the component thermistor. So the voltage of the thermistor, V thermistor, let us write V thermistor. This is the fixed resistor, and so this is the voltage across the fixed resistor. Now we have to calculate the voltage across a thermistor. As you see, the thermistor and the fixed resistor are connected in series. Therefore, whatever the supply voltage, it is divided among these two components. So we can write V of the cell is the sum of voltage of the thermistor plus the voltage of the fixed resistor. So that means 1.5 is V of the thermistor plus the voltage across the fixed resistor is 0.91. So V of the thermistor we can calculate as 1.5 minus 0.91. Please make use of your calculator to get the answer. It's giving an answer of 0.59. 0.59 volts. So let us write it here. The voltage is 0.59 volts. Now calculate the resistance of the thermistor. From Ohm's law we know that it is a product of V is the product of I and R. So to calculate the resistance of the thermistor, we have to know the voltage across the thermistor over the current flowing through the thermistor, which is the circuit current itself. The voltage of the thermistor we calculated as 0.59 over the current flow is, it's given a current of 0.2 milliampere. So we cannot use this as 6.2. So we have to change this milliamperes to amperes. So it is 6.2 over 1000, which is same as 6.2 times over minus 3, which is equivalent to 6.2 times 10 to the power of minus 3 amperes. So to change from milliampere to ampere, multiply with the 10 to the power of negative 3. So the current is 6.2 times 10 to the power of negative 3. So let's make use of the calculator to get the answer. It is giving the resistance as 95 ohms, resistance of the thermistor. Now the graph shows how the resistance of the thermistor changes with temperature. Describe the graph. 2 marks, so we can write it as 2 points. First of all, you can see that as the temperature increases, you can see the resistance was here, but when the temperature increases, the resistance is decreasing. So this is the first observation we are having. As the temperature increases, the resistance decreases. Then second observation is it's a non-linear graph. It is not a straight line, it is a non-linear graph. Now the last part is explain how the reading on the voltmeter changes when the temperature of the room decreases. As you know, the component is the thermistor, and we know that the resistance of the thermistor, it is depending on the temperature, inversely proportional. This is the property. So here the room temperature decreases. Room temperature decreases means we can write as temperature decreases. That means T decreases. Therefore, a resistance of the thermistor, they are inversely proportional. The resistance is increasing. So when the resistance is increasing, the circuit current is decreasing. I circuit, let me write it as the circuit current, I circuit, it is decreasing. As the resistance increases, the circuit current is decreasing. So when the circuit current decreases, the voltage drop across the resistor is decreasing. This is as the as the R value is fixed. It means we know that V is I times R, that is the voltage drop across the resistor, because they are asking how the reading on the voltmeter changes. See, the voltmeter is connected across the fixed resistor R. So the voltage across the fixed resistor, it is the product of current and its resistance value. And here, when the current value decreases, as the current value decreases, the voltage value also decreases. It shows that the voltage and current are directly proportional because R is fixed. This is the meaning. This is what it means.